Welcome back, everyone. So in the last lecture, we saw a bit of compilation process, and we saw that how can we convert our Java source code, which is in the form of .java extension, into the so-called bytecode, which is in the form of .class extension. But so this compilation process is platform independent. What it means is that it doesn't matter, like you can port this bytecode into any machine, and basically this bytecode will run on that machine, given that your target machine has Java runtime environment installed. And so what it does is that, Java runtime environment, it has this just, in-time compiler, which basically receives that bytecode and converts it into, you can say that exe format that we used to have in C++. You remember, if we in C++, we can compile our source code into the executable format. So this process happens within this container, within this so-called virtual machine that has to be installed at your target computer. And in this case, what can happen is that, for example, once you so if you say that, for example, Java, and then whatever your file is, that .java, what this does is basically it does this whole of this compilation and runtime process. So it converts your Java source code into the native code, and then runs it. And so if it has multiple statements of printing, then you'll see that those print statements being executed. But if you simply say that, okay, Java C main.java, then it will it will simply compile your code. It will not run that code. And so this process actually converts your Java code into your bytecode, but this command actually goes one step further and actually runs that code. Okay. Now, coming on to data types, we basically have two types of data types in Java. So for the first ones are primitive data types. These are somewhat similar to what we have in C. So for example, byte here occupies 1 byte or 8 bits, ranges from -1 to 8 to 1 to 7, and likewise short, integer, long, floats, and doubles, and Boolean and character. Each one has different capacity. For example, this long is 8 byte long, which means that if we have 8 bits and 1 byte, we have 64 bits to represent a long integer. And the ranges, and this ranges from -2 to the power 63 until 2 to the raised power 63 minus 1. So whatever that number is. The representation of floating point number it's a bit complex. It depends upon specific convention, but what can happen is that you represent your floating point numbers with bits allocated separately to your exponent, and bits allocated separately to your exponential number. But this is somewhat similar to how floats and doubles are represented in C as well. So byte here represents is represented in 1 byte, whereas character is represented in 16 bytes, which is, I think, somewhat different from C. So a single character, a Unicode character in Java is represented with 16 bits within this range, basically. So these are all so-called primitive data types, but you can also have these reference or so-called complex data types, which can store different types of objects. So for example, major reference types are strings, arrays, and custom objects. Let's see them in a running code. So for example, if we have strings, so first of all, this string is basically a class, once again, defined in where it is defined in this package. So well, this is also something important that I missed earlier. So everything belongs to some package, in Java. So we have this string class which belongs to, this java.lang package. Um, Sorry, and this class is defined at the java.lang package. So this final keyword basically suggests that I cannot inherit anything from string class. So I cannot define my customized class using strings, I suppose. And it is so it's not like it's not in like in Python, you cannot say that string is a simple array of characters. If you want to, let's say, access a particular character of that string, you will have to use a particular method defined in that string class, which is character at. Okay, and then you can simply say that, okay, print out whatever third the character at third index, or the last entry is in this case. But strings are immutable, which also means that these are also mutable in Python. You cannot simply say that, okay, string at some index is some other number. Like, this doesn't work. For example, it won't even compile, I think. You see, it says that I cannot treat this string as as an array. It should be an array, right? So this is simply string, which is like, you can treat them as a as an array of characters, but they are not internally implemented that way in Java. So this is simply a string class, and then we can have, if you want to define an array of strings, then you basically have to use these square braces, and this will simply mean that we are going to define an array of strings. And just like in C++, that how will we define that? We'll use flower brackets and define as many strings as we want. So this will be your array of string classes. This will be your array of string objects. Now, there is aliasing, which is very common in programming languages, which means that if you simply say that, okay, I'm going to define my second array, which is basically equal to one array, what will happen is that if you will change, any of these two arrays, if you say that, okay, I'm going to change this number into second, the second item, I'm going to, replace that string. What will happen is that this change will be reflected in both of these strings. Okay, so these strings are basically, this assignment operator says that both of these strings are pointed to the same data, stored in a unique memory location. Um, so this is simply printing, and then so these are basically, these two are examples of referenced data types, string and also array of strings. And likewise, I can also simply define integer array, for example, saying that, okay, this is simply an array of integers. Okay, so every primitive data type can be used with these curly braces in order to extend that data type into an array. um, what is it saying? Okay, it just says that I cannot use, it's not used, right? And then we can also have complex data types. So this point, for example, is defined in this package. So right now, so just like we'll use import statements in Python, we can also say that from this package import everything. Okay, and so therefore you'll see that this point is basically defined in that package. So you see it's defined inside this package. And this point has the constructor takes two integers basically. Once again, it's a customized object, which means that if I do this and change any x of any of these 2 points, basically the change will be reflected in all of these 2 points. So basically, whenever you are defining any reference type, you should be very cautious about aliasing. This assignment operator doesn't create a new object basically. Another thing is that whenever you use this new operator, like so, there are no pointers in Java. In C++ we have pointers as well as references, but in Java we only have references. Okay, so this will create a new reference and name it to PT1 basically. You can also have constants. So here I'm saying that, okay, C is a constant, which means that well, right now C is a simple float which has a value of 5.9. This capital F is necessary, otherwise it will simply say that cannot convert from double to float. It will automatically assume, so you'll have to use this literal F to define your floating point numbers. Another thing is that if you want to define your constants, you can use this final keyword. If you use this final keyword, this means that you cannot simply go on to program and then say that 6 x is something different. It will say that well, right now it says that I have not used this semicolon, but you cannot simply say that variable x is basically it's a constant, so therefore it cannot be reassigned to some other value. So this final keyword, when it is used with the with some object, it basically enforces it to be a constant. But then you can also use this final keyword to, for example, if you have a method, if you have a class, if you have defined a class, for example, I remember that we saw, I think, right, so we see that this string is a is there is a final keyword which basically suggests that you cannot inherit from the string class. Okay, so inheritance cannot take place if you define your class to be a final class in some sense. If it's a primitive data type, if x is a float, then this means that you are defining a constant. If x is a class, then you are preventing inheritance in some sense. And if x is a method, just like this print ln is, for example, this print ln is a method of this out type object. Okay, and likewise, this character at is also a method of this string object. If you say that some method is final, then this means that you cannot override this method in your children classes. So this final keyword has basically 3 different types of meanings given the context that you are using this final keyword. Okay, so this concludes our primitive F and reference data types. In the next video, we are going to see conditionals and if-else statements within Python.